So now let's talk about displays. I guess we should start with what a display is, and of course we sort of know, but the idea behind a display is it supports the perception of relevant information and variables that we're trying to display. It helps facilitate decisions. Examples, of course, are things that you see all the time, speedometers, messages on phones, etc. The idea behind designing good displays is similar to the idea of perception in general when we talked about sensation and perception previously. We want to maximize the bottom-up processing that people are making use of. That is, we should improve the contrast and the size and all of those kinds of physical stimuli that people are processing. But we should also take advantage of these big brains that people have that enable them to sort of anticipate what's coming next. We focus on sort of their expectations, and provide the best opportunity for guessing and context that we could possibly provide. This is improving both the bottom-up processing, that is the actual stimulus, as well as the top-down processing, the ability for people to anticipate what's coming, because often we see what we expect to see, and that facilitates our performance. So let's start by talking about the bottom-up aspects. There are three important characteristics. One is simply the visibility of what it is you're trying to show. That is, people should know that there's something available that can be detected. The second is legibility. That is, people need to be able to look at each thing, whether it's a character or an icon, and it ought to be able to be identifiable. It should be different than other ones that are on the screen so that people can discriminate one from the other. And then the final part is readability. It enables recognition of the information content. And of course that happens with meaningful groups like words and sentences, but also meaningful groups on the design of your user interface. You need to be thoughtful about where you're putting information on your display. So as we continue talking about the bottom-up processing, we can talk about the size of things like text. Now this is set for hard copy, and we'll talk a little bit about computer copy here in a little bit. But if you're designing hard copy text for all kinds of things, books, but also signs and so forth, there are a few things you should know. You're familiar with the idea of font size and so forth. And what you probably ought to know, you're probably familiar with 10 point and 12 point and 14 point and all that. 1 point basically equals 1/72 of an inch. On the other hand, to include ascenders and descenders, it's really better to think about it as 1/100th of an inch. And an ascender are things like on an H, for example, it goes up past the, past the first sort of loop part of a lowercase h. A P has a part that drops below the line. Those are ascenders and descenders. And people typically read books and technical documentation and things like that somewhere between 12 inches to 16 inches. For those kinds of things, on hard copy, usually a 10-point font for that distance is pretty reasonable. The text height and the key elements for being able to see things that are really important. So, titles, for example, warning signs, those should be a half a degree of visual angle, at least. Dynamic or critical elements that are not, the overall big picture should be about a third of a degree of visual angle. And then static or non-critical items should be about 0.27 degrees of visual angle. And the visual angle is basically the angle that subtends the image on your retina, and that's provided for you in the Wickens book. There's some other things, actually, and one of them is the sort of stroke width of the text that you're looking at. So, for example, here you can see that from far away, this actually might be a little bit difficult to read. If you were some distance away, maybe you were looking at a sign, for example, the ratio of the thickness of the stroke, which is this, to the height of the letter, which is this, that's also the thickness of the stroke there, should be somewhere between 1 to 6 or 1 to 8. So you can see actually from a real distance, this is actually easier to read. So if you're designing things like signs, for example, this would be easier to detect, especially in things like reduced light and so forth. These things become easier to read. That's also true of the width to the height ratio. So here's the, oops, sorry I did that. Let me see if I can get back. Hopefully your eyes aren't spinning since I did that. Okay, here we go. So here is the width, here is the height. You're actually better off having the width pretty darn close to the height in terms of making things visible, especially from quite a distance. Of course, make sure you use familiar stimuli and familiar typefaces and so forth. And this is important. Use a serif font. Serif fonts tend to have, in fact, this is a serif font that I'm using here, interestingly. It's an ASU template, though. But you see these little sort of hats and little feet sort of on these text. They're little extenders and descenders, sort of. That represents a serif. And those are really useful for hard copy. It enables people to read them faster and so forth, especially on hard copy where you have really good resolution. The problem is most computers, even these days, don't have nearly as good resolution as paper. So for paper, we tend to use sans serif fonts. Sans serif fonts are those like Arial and Helvetica and so forth. Those are best for reading quickly and for recognizing things quickly on a computer, whereas serif fonts tend to be better for hard copy. There's symbol spacing, which is how much distance there should be between two items in a text string. Here, for example, this is a little harder to read from a distance. Again, this is from a distance than this is. A little bit more distance between the two characters make this a bit easier to read. And a similar kind of scenario applies to the stroke width. Wider is better up to about a height character to height ratio of about 1 to 6. The other thing that's absolutely critical in the design of text is the contrast. You have to provide enough contrast for people to actually be able to read things, especially if they're reading them from far away. And in fact, you can even have smaller text if you have better contrast. You probably want to provide symbol contrast between 3 to 1 and 7 to 1. That is, the dark part, or actually the light part, the background, should be at least 3 times lighter than the foreground, or as much as 7 times lighter than the foreground. Avoid all capitals. One of the reasons is that you can see in mixed case there's a lot more variability in terms of these letters. You can see there's different sizes, for example. Some will even drop below the line and so forth. That's not the case in capitals. In capitals, they're all the same size. And as a result, it's harder to discriminate each word from every other word. Whereas here, there's lots of information to discriminate each word from every other word. And as a result, you can discriminate and sort of make sense of what you're reading largely by the shape of the text. And you don't have to do so much work like you would have to do here. Besides that, there's also this notion that when you use all capitals, it's sort of like yelling. Avoid confusion between similar characters. So for example, if you have, an item number on something that you have to order on the computer, certain characters tend to get confused. And here's a list of them: S and 5, I and L, X and K. These tend to be highly confusable, especially when people are multitasking. On computer displays, people tend to read slower in general. There's lower resolution. They usually sit at a farther distance. It's getting better every day, but people don't read as quickly on computer displays as they do on paper, even these days. Here is some information about text size. The minimum character height of a capital letter should be 16 minutes of visual angle for reading task. So that's a minimum height of about almost 1/10 of an inch. The preferred height, on the other hand, is 20 to 22 minutes of visual angle, which is a preferred height of about 0.12 inches. So this provides you just some background information for text size on computer displays as you're designing user interfaces for computer displays. You've also noticed that some displays will have what they call reverse polarity. That's basically characters can be dark against light, or they could be reversed. They could be light on the dark. It turns out that the light background tends to reduce glare and is probably the best in terms of reading speed and so on. Usually in fact, this is sort of the sign of a beginning designer, that they include way too many colors in their interfaces. So I typically tend to design for monochrome first using spacing as much as possible, and then I apply color to the design of whatever user interface I'm providing. But there's all kinds of other things you can do. So some things to avoid, on the other hand, are things like avoiding extremes of the color spectrum. So for example, you may notice that when you put reds and blues together, you end up with this thing called chromostereopsis, which is this perception of depth when those two things are together. Your eyes sort of bounce back and forth, which is really fatiguing. Finally, the idea is to make sure there's only as much information on the screen as you really need. Otherwise, the screen turns too dense. Density is sort of the percentage of available character spaces being used. And as a screen is more dense, the search time and the likelihood of errors increase with that density. So there's a couple ways to think about density. There's sort of global density, density on the whole screen, but even within a small component of the screen, there can be local density. So for a certain small component of the screen, there can be the number of filled characters near other characters. And it can be really useful to provide as much white space as possible between these things. On the other hand, the only case where you don't want to include a lot of white space between things is when they ought to be in a group. Because in a group we're trying to take care of and make use of our Gestalt rules of thumb, our Gestalt heuristics or principles, and those things that are really similar to each other, really related, ought to be close together.